Hello, this is question 2 from the 2008 MAT. First part of the question, find a pair of positive integers x1, y1 that solve the equation x1 squared minus 2y1 squared equals 1. So positive integers, well, we can't have 1 for x1. We have 2, 4 minus 2. No, so we can't have that. X1 is 3, would give us 9 minus... Yeah, we could do 3 and 2, couldn't we? Because we'd have 9 minus 8 equals 1. So just by trial and error, we got x1 is 3 and y1 is 2. Okay, so that's the first bit. Given integers a and b, we define two sequences, x1, x2, x3, etc., y1, y2, y3, etc., by setting. Okay, so we've got these sequences, xn plus 1 is 3xn plus 4 yn, etc., for n is greater than or equal to 1. Find positive values of a and b such that this holds. Right, so this is the same thing that we got on the left-hand side there. And the temptation is to put 3 and 2 in for, put in x1 and y1 and see what happens. But let's try doing this slightly more rigorously. Maybe I'll do that afterwards. So we've got what xn plus 1 is and yn plus 1. So let's sub those in. Let's sub in that. So we'll have 3xn plus 4yn. So that will be squared for our xn plus 1 term. Then we've got minus 2axn plus byn. That will be squared. And that needs to be equal to xn squared minus 2yn squared. So let's expand out and see what happens then. So we're going to have 9xn squared plus 16 yn squared plus 24xn yn minus 2a squared xn squared minus 2b squared yn squared minus 4ab, dropped off the screen, xn yn, and that is going to be equal to xn squared minus 2yn squared. Okay, I'll try and imagine that all on one line. Right, let's have a bit more space then, putting this all together. How many xn squareds have we got? That's that term, that term, that term. So that will be 8 minus 2a squared. 8 minus 2a squared. That's our xn squared. What about our yn squared? That's this one and this one and that one. So that's 16 plus 2 is 18 minus 2b squared. Okay, that's the yn squared. And then for our remaining terms, of which there are just the two, we got 24 minus 4ab, and that is xn yn, and that's got to be equal to 0 for this to hold. So each one of these brackets has got to be equal to 0. So we've got 2a squared is equal to 8, so that gives us a is 2. This one is giving us 2b squared is 19, so b is 3. Does that fit with this bracket? 24 minus 4 times 6 is 0. Yes, so that works out fine. So we've got a is 2 and b is 3. What would have happened then if we had actually put these in? If we'd done x1 and x2, so if x1 equals 3, y1 equals 2, then that means that x2 is going to be 3 lots of x1. That gives us 9 plus 2 lots of y1, which is 4 lots, of y1, which gives us another 8, so that's 17. And then we'd have that y2 would be equal to, well, say we didn't know what a say we didn't know what a and b were yet. I'm just intrigued as to what would have happened if we'd put all of this in. So we'd have a times x1, so that'd be 3a plus 2 times b. So we've got those, and we'd be saying then that if we apply the same process, so the x1 squared plus minus 2y1 squared, let's do this with x2 and y2 and say that's going to be equal to 1 then. So we'd have that 17 squared, that's our x2 squared, minus 2 lots of y2 squared, we're on to now, so that squared would have to be equal to 1. So 17 squared, okay. Right, we'd have 17 squared minus 1 over 2 is equal to 3a plus 2b squared. Obviously, we don't need to do all of this because we've solved this properly up here, but I just want to know what happens. Difference of two squares, so that'd be 16 times 18 over 2. 16 times 9 is 144. Square root it, 12. So we'd have 3a plus 2b equals 12, where a and b are positive integers. And the only way we're going to do that is have a equals 2, b equals 3. Right, okay, so it comes out in the same place, but less satisfactorily than doing it in this more rigorous, just keeping everything as ends approach. Anyway, that's two ways of going through that part of the question. Find a pair of integers x and y which satisfy x squared minus 2y squared equals 1. So we've got the same term here, the same expression on the left, such that x is greater than y is greater than 50. Right, well, anything that fits in this sequence with a is 2 and b is 3 is going to be satisfying this equation. I mean, that's what we've said. So what would this term have been here? We've got 3, so that's 6 plus 9 is given, is that right? 6 plus 9? No, 6 plus 6. I'm getting my 2's and 3's mixed up here. Yeah, 3a is 6, 2b is 6. So y2 is equal to 12. So 17 and 12 also work then. But that's not in this range. So let's just keep going until we hit something in that range. So x3 is going to be equal to 3x2. So 3 times 17 plus 4 times 12. Plus 4 times 12. Right, so that is 51 plus 48, which is 99. So that's in our range. So I'm assuming that y3 is going to get between 99 and 50. So y3 is, a is 2. I keep picking up the wrong numbers on these. So a is 2, and so that's 2 times 17, plus b is 3, 3 times 12. That's going to be in the range, isn't it? That's 34 plus 36, which is 70. So we are saying then for x and y, so that is our capital X and that is our capital Y. Okay, so that came out okay. Small part of the screen left for the last part. Part 4, using the values of a and b found in part 2, what is the approximate value of x divided by y as n increases? Right, okay, what are we going to do with this then? As n increases, what is the approximate value? Well, we know that these numbers are just going up. They're always going to increase. Everything's positive. Nothing's ever going to be going downwards. So we've got, what have we got anyway on this? We've got the xn squared. Let's just separate this off. We've got xn squared minus 2yn squared is equal to 1. Whatever value of n we've got, that is going to be the case. And we're saying that xn and yn increase with n. They're never going downwards. We've already established this from those sequences. So what are we going to do about this then? Well, we want this ratio. We want to get xn divided by yn. So let's divide by yn squared. At least that will get us an expression with it in it. So we can say xn squared over yn squared minus 2 equals 1 over yn squared. Okay. And this term on the right is going to, that's going to tend to 0, isn't it? Because yn is getting bigger and bigger. So this 1 over yn squared tends to 0 as n tends to infinity, because yn just keeps on increasing. So as n gets bigger, which is what we want, as n increases, we are going to get that xn squared over yn squared will tend to 2 as n tends to infinity. So that's the squared of it. So we want just the square root of that. Therefore, I've run out of the screen here, but anyway, therefore xn over yn will tend to the square root of 2 as n goes to infinity. Yeah, okay, that wasn't too bad once you get into it, but it's one of those ones you don't really know where you're going. Well, I certainly didn't at the start. It's a case of, well, let's write down what we know, these two things. That's the two things that we worked out. Try and produce this ratio in the equation that we've got, i.e. divide by yn squared, and then just see what happens then. So, yeah, piecing it together as you go along. But that was fine. Didn't need to do all of this bit down here of that alternative sort of cheaty way of working out what A and B are. But it came out okay. I don't know how they'd assess the relative merits of this method up here of keeping everything as xn and yn, or this method down here. I don't really know what they'd make of those two options. They both come out with the right answer, so they're not disasters either way. But yeah, I don't know which one they'd prefer. The rest of it was there was only really one way to go, I think, on those. Yeah, nice question anyway. First long one on this paper.